Good day viewers, welcome to my YouTube channel. Today we'll be looking at composition of functions. So in this lesson we shall discuss how to find the composition of functions and to find the domain of a composed function. If you are a new viewer or a returning viewer and you haven't subscribed yet, make sure you subscribe and very important. Alright, so let's get started with our first agenda, how to find composition of function. So first of all, what does composition of function means? Now if I have a function, let's say a function that maps from x to y, and then I have another function, let's say g, that maps from y to z. So what does the composition of G and F means? So this composition. So composition is also a function, okay? Is a new function, okay? And what is it all about? So you can compose a function. If you look at function f is mapping from x to y. If you look at function y, is mapping from y to x to z. So what you should observe here is that the output of this function f is becoming the input of this function g. Like what is coming out of f, like as an output, like the image now, is becoming the domain in your g. So that is the meaning of composition of function. So if we compose this function like this, it will move from x to z. Okay, x to y, y to z. These two parts are the same. Like these two guys are the same. So composition of function will just move from this x to z. But the main thing you need to take note of here is that the output here of the f is becoming the domain in the g. So this can also be written as g of f of x. Okay, so you can see that the domain of g now, which is initially g of x now, or let's say g of y, because the domain here is y. So which is initially g of y is now becoming g of f of x. So because the domain of the g has been replaced by the image of f. So f is f of x. So f of x is an image. So the image of g, the image of g now, the domain now has been replaced by the image of f. So that is just what composition is all about. So let's look at an example. Don't worry if you don't understand what I'm saying. So if you look at an example now, you will understand. So say given that f of x is equal to x cubed plus 3x, and g of x is equal to the root of x. So you have to find the following. So find f of g of x, b, find f of g of x maybe at 1, c, find g of f of x. Done, please. Should be g. So g of f of x. Then d should be g of f of 2. Okay, so let's talk about the solutions of the following. So starting with A now, so we are looking for f of g of x. So g of x now, this is g of x, is defined as the square root of x, okay? And f of x is defined as x cubed plus 3x. How do we find f of g of x? Very simple. So f of g of x is what we are looking for. So in the domain of this f, we are going to replace it by this g of x, which is root x. Now, in place of the x in f of x, we are going to replace the x by root x. Like anywhere we see s, we put root x. So that would be root x raised to the power of 3 plus 3, then root x. And that is all. So the second part says that we should find f of g at 1. So what that means is after you've done the composition, you insert 1 in place of g, in place of x, sorry. So we have 1 square root of 1 raised to the power of 3 plus 3, times 1. So that will just give you 1 plus 3 and you get 4. So going to C now, we have g of f of x, so which is the other way around. So in place of f of x, we have x cubed plus 3x. And if you, in place of x now in g of s, the x that is here now, you put s cubed plus 3x. Like anywhere you see s, put s cubed plus 3x. So in that manner, we get s cubed plus 3x. So before we, okay, let's do d now. We have g of f hat 2. So what that means is we just have to put 2 in place of the answer we got. And that will give you 8 plus 6. And that will give you the square root of 14. So I want you to observe something, like a remark. So you should observe something from here, that f of g of x is not the same as g of f of x. So f of g of x is not the same as what? G of f of x. So they are not the same. So if you do f of g of x, don't think that it will be the same as g of f of x. So it is usually different. Alright, so let's do another example. So given okay, so find a f of g of x and b h of f of g of x. So these are the instructions. Okay, so for a, we have f of g of x. So what do you do? So in place of g, we write 1 over x minus 2. So in place of x in f of x, we replace the x. S is defined as s squared. So in place of this s now, we are going to put 1 over x minus 2, like substitution. So we get sine, then we get 1 over 1 minus x, everything squared. So which is same thing as 1 over x minus 2 squared. Alright, so for the b, we have h of f, then g of x. So we are composing, the composition of function is being composed again. So the same principle is being applied here. So you just pick this f of g of x that you've gotten, you put it in place of the, like that will be the image of, that will be the domain of the h. So you have sine 1 over x minus 2 squared. So this is now the image of the h, the domain of the h, sorry. So in place of x, we just insert this there. So this would be x is x squared here. So we just get sine 1 over x minus 2, everything that we had before. Then you put a square on it. Then you say plus 1. So this is exactly what you will get. So if you have any question, you can always drop it in the comment section. I will look into it and give you a response. Okay, so moving on, now we'll be talking about domain of a composed function. Okay, so now let's do an example. So say given f of x is equals to x over x plus 1 and g of x is equal to 4 over x. So find the domain of f of g of x. Solution. Okay, now how do you find the domain of a composed function? Now pay attention to this. To find the domain of a composed function, you don't many of us will just say, okay, let's just look for the domain, let's just compose the function. So from the function we've composed, then we now find the domain of that composed function. It doesn't work like that. You see, to find the domain of a composed function, you need to find the domain of the inner function, like that g of x that is inside. You need to find the domain of that one, and then do your composed function, find the domain of that, and whatever restriction you have in both is what you consider to be the domain of the whole function. Now this is what I'm saying. So we have g of x to be equals to 4 over x. So what is the domain of this function? So the domain of g of x now is what? So it's going to be the value of x such that s won't be 0. You understand? Because if s is 0, you get undefined. So we just have to ensure that we don't have undefined, like we don't have an error when we input our function in calculator. If you press 4 over 0 in your calculator, you get undefined. But any other value that s assume at the denominator is always sweet, and calculator will always give you a nice answer. Okay, so now if you look at, so this is the first step. You find the domain of the g of x first. Now you do the compose function. So you put the 4 over x inside. So in place of x, we put 4 over x. So we have 4 over x over 4 over x, then plus 1. Now this is 4 over x. Okay. Alright, let's do LCM here. So LCM of x and 1 is x. And then we get 4 plus x into 1 is x. X times 1 is x. So that is what we get. So now this is divide. So you write it as divide, then you get 4 plus x over x. So you know what we'll do there. You change that division to times, then you get 4 plus x. So this will give birth to 4 over 4 plus x, which is the final result. So we just have f of g of x now to be equals to 4 over 4 plus x. Okay, so now what is the domain of this function? So the domain of this function now, of this new function we have, is what is, you just have to ensure that this guy is not 0, like it's not 0, and what will be the value of s that we ensure that this is not 0? So that is if s is not equals to what? -4. So as long as s is not equals to -4, then this function will be defined at any value of x. So the domain of the compose function now, which is what we are actually looking at for. So the domain of the f of g of x now. So what will it be? So we have two guys. We have s is not 0 and we have s is not equals to -4. So if I should put that on a number line, so this is what I normally use that helps me to get the domain. So I'll put -4 here and then put 0. So we know that s can be 4 and s can be 0. Okay, here we have -infinity, here we have positive infinity. So what happened here is that if I'm to draw a line now, my line from this -4, these are values of x though. So x is, we go like this, s will go like this, and s will go like this, like here to be in between. So s will also go like this. So at the end of the day, we have -infinity, then -4. S can be 4, so you give an open interval. So union, for the middle you have -4 and then 0. Then the last one you get 0 to infinity. So that is the domain of the function. Okay, so moving on, we have another example to look at. Say given g of x to be square root of x minus 2 and f of x to be equals to 1 over x squared minus 1. So find the domain of f of g of x. So I want you to pause this video and attempt this question yourself. Try to solve it and get the domain. Before then, when you are done, you can now continue playing the video and observe. So please, if you haven't subscribed, make sure you subscribe. Now let's solve it. So just like we did before, we are looking for domain of f of g of x. So you need to find the domain of g first. So the domain of g is just, this is a square root function. In a square root we shouldn't get a negative number. Okay, so meaning that my s minus 2 must be greater and equals to 0. So these are like positive numbers, starting positive numbers. Okay, so although 0 is not a positive number, but 0 can be inside your square root. Okay, so from here s is greater than 2, so s must be greater than 2. Now let's look at the compose function and then try to get what the domain gives us. So we have f of the square root of x minus 2. Okay, so in place of s we put that, so we get the root of x minus 2 squared then minus 1. So this gives you x minus 2 minus 1, that is x minus 3. So following this guy, the domain here will be what? Will be s minus 3 not equals 0, then s is not equals to 3. So we have two range here. We have s greater than 0 and then we have x is not equals to 3. So what will be the main domain of this function? So you put the 2, you put the 3. We have s greater than 0, so x will go like this, and s can't be 3, so there will be a hole here. S can't be 3, so you have to break it, then it will continue. So the domain now will be in between 2 and 3. 2, okay, it can be 2 because we have s greater than equals to 2, so here will be close. This will be a close interval there, and 3 will be open because you can't have 3. So you open it here and then you go to positive infinity. So this is the domain of the asked question. Alright, so I hope you enjoyed this video. Thank you very much for watching this video to the end. See you in the next video. If you have any question that you want to ask, you can always drop it in the comment section. I will check them and give you a reply as soon as possible.